Dan, I'm going to go ahead and turn it over to you.
Good. Hi. We're going to cover 4 areas here, or 4 lines: Honeywell, Maxon, Iris, and ASCO. And the areas that we're going to cover are, we're going to go over some safety issues, because in being out in the field out there, we discovered that some people are unaware of some very basic safety issues with flame safeguard. Just want to refresh them on that, and then go into 4 areas where people can reduce costs. The primary one being replacing obsolete controls, how you save time and effort and money when the flame safety actually trips out, how you can reduce your fuel costs by going to fuel-air ratio control, and also what it means to do valve proving and how that can actually save you money in the long run. On the first issue of safety, there are UV sensors called dynamic self-check. We're going to go over 3-4 slides on that. We're going to touch on what happens when you have a user circuit, meaning when you combine stuff that is flame safeguard stuff with other stuff out there. We're going to look at a couple code issues, and finally, because some people are being involved with safety instrumented systems, who has SIL ratings on this kind of equipment that can help people implement those SIS systems. On the UV field, UV flame sensors have a tendency, when they're exposed to continuous flame, to either what they call run away or burn in. And what this means is they see a flame when there is no flame. Well, this is contrary to what flame sensors are all about, because they're supposed to detect flame when there is flame and then tell you when there is no flame when the flame disappears. And again, this happens when the UV sensor is exposed to continuous UV over a period of time. Well, the codes recognize this, and their code specifies, all the codes specify, that if a burner is on continuously for more than 24 hours, it requires some form of self-checking in order to detect this runaway or burn-in situation so that it can be rectified. So how does self-check prevent the runaway? Well, there's actually a shutter mechanism in there that actually closes off the port and makes sure that the UV sensor does not detect UV when the shutter is in place. And then the shutter opens, and you get UV back in, and all the electronics take care of all this sequencing and timing stuff. Honeywell calls this specific technique dynamic self-check. The little sensors, called mini peepers, do not have dynamic self-check. The bigger ones that people call purple peepers do have dynamic self-check. There's an older model called the C7012, a newer model called the C7061, and a little further on we'll go through why you should probably replace the older ones, the legacy units, with the newer ones because of the cost savings involved there. On the user circuit issue, we found a lot of people out there will take a standard gray box flame switch type control, and they'll add to it something like a timer to do their purge timing. And we want to make them aware that the combination of those 2 devices does not necessarily make the same thing as a device designed for and sold for the purposes of doing purge timing and flame safety. And the classic example is when we went in and the design actually called for 4-minute purge, and the operations guy said, oh, we've got the purge timer down to 15 seconds because he was saving 3 minutes and 45 seconds. The problem is that purge times are designed to evacuate the combustion chamber, not to speed up the production process. So people should be aware that there's a liability that resides in the user when they have external circuits doing stuff like purge timing that are not included in the flame safety box itself. And the flame safety boxes are designed to do that purge timing as an integral function of what they're designed to do.
Could I ask a quick question?
The practice is to let the flame safety controller do what it's supposed to.
Quick question.
Yeah, go ahead.
This slide looks like that the purging is outside of the flame safety system. Is that true? Is that code? How does that work?
Well, it's the code doesn't specify where the timing has to come from.
Okay.
But the point is, sometimes self-insured people will say we're going to do all of this on our own. okay, and they'll get a flame sensor and run it into a PLC and do it that way. And obviously the PLC is going to do the timing function. But you should be aware that these standalone flame safeguard units have a purge timer built into them, so that box takes on the function of purge timing if that's what you're going to do in a smaller system that doesn't require a full-blown PLC control that you're going to dedicate for burner management. Does that answer the question?
Okay, yes. Thank you.
Okay. Yep. On the safety-related issues, we're going to cover three things real quickly here. One is the annual leak test on the valve trains, a real brief touch on the SIL certificates that are available, and then one that we found people aren't also aware of is that the NFPA 96 actually banned the use of 220-volt controls and required the use of 120-volt controls. On the annual safety audit, all of the CSD1 is for smaller boilers, NFPA 85 for large boilers, and NFPA 86 is for ovens, kilns, and furnaces. All of these require an annual leak test on the fuel valve train, and we found that many facilities are just not aware of this. What's the leak test involve? Well, on the gas train, you got your double block and bleed valves, and you got to typically have a vent valve, or sometimes you have valve proving. But the idea behind a leak test is to make sure that the safety shutoff valves actually shut down when they're supposed to, and that when they shut down that they are actually tightly closed and that they're not leaking gas. So the test of a valve involves taking an access port, a plug out of an access port, hooking up a flexible tube to it, sticking the flexible tube in a bucket of water, and then going through a 10-step procedure is in terms of where you apply the pressure and how much pressure you apply to count the bubbles coming up out of it. People ask, well, what's an acceptable leak rate? Well, it really depends upon how many bubbles over what time and what size pipe, but there are published tables that show what that is. Maxon actually builds their safety shutoff valves to that table on the bottom, which is an ANSI Class 6 leak rate table. In some jurisdictions, the authority having jurisdiction will come in and say, this is an acceptable rate. In other places, they don't care. They just say, what's the manufacturer say, and then you go back to the manufacturer tables. But the point is, if a safety shutoff valve doesn't seal shut, then it's not doing what it's supposed to. And this really becomes evident when we walk through places and we see some safety shutoff valves that have been installed for 25 or 30 years. You have to ask yourself, with cycling and dirt and grit over that period of time, how well are these valves actually sealing? And that's what the annual leak test is supposed to show people is, yes, the valve will actually open and it'll shut, but when it shuts, is it actually doing its job? Is it actually cutting off the fuel flow?
Excuse me, what is on that last slide, AHJ? What is AHJ?
Yep. Authority having jurisdiction.
Ah, okay. All right.
In some places, that's the fire marshal. In some places, that's the safety department. It depends on who it is.
Okay. Thank you.
Yep. On the SIL rating certificates, Honeywell has a SIL certificate that's there. The image is up on the screen up there for the 7800 blue box controls. Is this, out of curiosity, is this something you've been involved with at all? Do they look at that situation down there?
I have not been involved with this yet.
Oh, okay. Generally, this is more important to people who build their own burner management systems by using sensors and PLCs than by the people that just put in the blue boxes and let the blue boxes do the work on it. But what it involves is you have to have certificates that tell you how fault tolerant a given device is, and the certificate gives the information on there that it has a hardware fault tolerance of 0, and then the people calculate that out. Maxon also has a SIL 3 rating, and they do that through Exceeda, which is an independent agency that they hired to actually assess the lifespan of their safety shutoff valves. The last topic on the safety here is the 120-volt operation. This goes way back to the mid-90s when it became apparent that people that were operating with 220-volt control, where the 220 volts is like residential, where they have a neutral in the middle, that you can get a false situation that can't be detected by the control, and therefore the control won't shut down. It's only of interest to people that run in that mode. We have a document number that if that's of interest to you, we could send that out and show you. What's happened over time, though, is that since this is almost 15 years later, the U.S. companies have not been selling 220-volt controls for 15 years now. So this only comes up really in a replacement situation where if people have this, they should be aware that according to code, they should actually put the system in for 120-volt service instead of 240-volt service. Now I'd like to cover 4 major areas where we see that people can actually save money and working with controls. And the first one we're going to cover is replacing obsolete controls. There's a lot of these gray boxes out there. In fact, a lot of people can look at that gray box and say, oh, that's an RA890 because it's been around for 50, 60 years now, and it's people just know them by their part number. What this slide shows is the comparison of costs for just replacing an existing gray box as opposed to replacing it with a newer microprocessor-controlled blue box. The RA890 is still available out there because there are literally millions of them still in service, and you can buy one for $1,500. On the other hand, you can replace it with an RM7895A for about $650. It requires the flame amplifier module that plugs in there for about $250. If you're going to do it, you have to actually, in this case, put a new sub-base on there because the wiring for the blue boxes is different than the wiring is for the gray boxes, and you need the purge timer. So you total all that up, and it comes to a little less than $1,000. Well, the $1,000 in comparison to the $1,500 price is 2/3 the price by going to the new one versus the old one. So people say, well, what do I get if I actually go to a blue box? Well, the first thing you get is you get a lot more information displayed for you. The gray box over here just has a light on it that tells you that it has power. The blue box has the series of LEDs down here that tell you where it is in the firing sequence. And if you put the optional display on it, it has all sorts of other information up there which can be valuable over time, like what the flame strength signal is. And there's numerous diagnostics that are also available out of that display. So you get more information right off the bat, plus you also get the lower cost, about 2/3. Now there's actually a second alternative here. The original one that I put up there was called the core control, and those core blue boxes have been out for the last 25, 27 years. In that 25 or 27-year period, they've made enhancements to them, so they have enhanced versions. And if we compare the enhanced version control to the old gray one, we still have the price of $1,500 to replace the gray box. Now we're down to about $570 for the replacement blue box. And if you look at the bottom down here, we're down to 61% of the replacement cost of just going back with the old style gray one. So I've summarized that here. You can replace it with one of 2 blue boxes. One is 2/3 the cost, and one is 61% of the cost of the other one. This slide goes over what the enhanced models offer over the core models. And these are the enhancements that have been put into the blue boxes over the last 20 years, so you get what they would generally term in marketing terms the latest and the greatest. One of these is the ability to have these new enhanced boxes do valve proving. And I'm going to go over valve proving in a couple other slides there to show you actually what the sequence is on that. There are fewer of these enhanced models than there are the core models. So if you have multiple burner control systems out there, you can probably do with 2 or 3 spares instead of 7 to 10 spares for controls out there, because one control of the enhanced version covers probably 3 or 4 models of the older legacy units. There is a run test switch on the top of these blue boxes, which people use for pilot turn-down tests on interrupted pilots, and that was you had to buy a specific model for that for the old legacy ones, but all of the enhanced models come out with that run test switch on it. People have found over time with the diagnostics on these that although FMs considers these boxes good for 100,000 cycles, but they will typically run somewhere between 200,000 and 300,000 cycles. So the new models give you a 1 million cycle counter on them, as opposed to the old legacy core units that only have a 100,000 counter in them. There's a whole series of techniques of flame safeguard called pre-ignition interlock, and all of this pre-ignition interlock stuff applies to the new boxes but doesn't necessarily apply to the old ones. And it also, if you have oil burners, it has programmable post-purge on it. And in summary, that these might seem to be smaller things. If I was looking at it, I'd probably say, yeah, I'm not sure whether I can actually use any of these, but I can actually save 5% in buying an enhanced control over buying a legacy control. When you're talking about a $1,000 unit, the $50 is worth it to buy the enhanced control. Here's actually a price comparison page that shows you on the left-hand side here we've got core units and then their enhanced replacements. Some of them can be only a $2 difference, but some of them can be a $250 difference. We have a chart. Oh, I got it on a slide down a little further down there. Where is it? I'll pop through it in a minute here. Before we get there, let me just run over. There are other obsolete controls out there. Anything in a gray housing from Honeywell is an obsolete control. Listed off the model numbers there, but just be aware that some of these are still available, some of them aren't. The R4140 has been obsolete for 17 years now and actually is not available even as a replacement control. One has to go to a microprocessor unit in order to replace it. This old solid blue box is the 7795 that's no longer in production. The programmer boxes that have these remote displays, the CB Hawk and 7700, are no longer available and also have been obsolete on the 13, 15-year period now. This one shows what the original 4140 was with all of its cam drivers in there. It was replaced by the BC7000, which is also now obsolete as the very first generation microprocessor control, but there are replacements for all of these available. This is a chart that actually shows the conversion table. It shows the list of all the core controls in the column here. In the row over here, you get the replacement leg or the new enhanced controls. And in order to upgrade, we recommend that people replace and rewire the subbase, just because a lot of these controls, by the time they wear out, they're 15 years old, and a lot of times it's worthwhile to replace the subbase because the subbase is a plug-in unit, and you want to make sure you have good spring contacts on there so that you don't get nuisance trips from bad contacts on the subbase. Some of them require a jumper wire, but there is an instruction sheet that comes with it that tells you whether or not you need a jumper wire in there. What I find in talking to people about upgrades is that the natural tendency of people is to wait until the old control fails, and then it becomes a crisis. And in the crisis of having the unit shut down and not operating, the idea is to get it fixed as quickly as possible, and it's just easier to get the old part number than it is to figure out what the new part number is and go through any changes. So that the real obstacle I find upgrading and really taking advantage of saving a third on this kind of stuff is that you actually have to plan ahead and say, okay, if we've got this, what are we going to replace it with when we go to that point, and then plan for it so that you've got the stuff all lined up and ready to go, and or even do it beforehand before you actually have a catastrophic failure. There's an issue about rebuilt controls. There are outfits that sell rebuilt controls, and if you go on the web, you can find places that sell rebuilt Honeywell Flame Safeguard controls. The issue with those is both safety and liability. There's absolutely no guarantees on the rebuilt controls. They probably are functional when they come out of the box, or otherwise the rebuilder wouldn't stay in business, but you have no idea about the quality of the components that they use to actually rebuild the controls. The bigger issue in my mind is actually the liability. When any of the vendors, original vendors, whoever it is, FireEye, Iris, Honeywell, whomever, sells you a control, the liability for the function of that control is on them. When a rebuilder opens the box and changes anything in there, the liability transfers to the rebuilder. These people can typically be garage shop operations that, literally say, oh, well, it didn't work, so sue me, what are you going to get? And when we're looking at where flame safeguards go, that's probably not a wise trade-off or a prudent trade-off to try and shift liability onto somebody that doesn't use factory OEM parts, has quality that could be anywhere on the spectrum, and frankly doesn't have any assets if in fact it proves out that their rebuild doesn't work the way that it should. There's another issue on upgrading, and that's these purple Peeper units. The original one out there was the C7012, and this is an enormous savings here because you get better performance at literally half the cost when upgrading from a C7012. The original 7012 actually have the electronics built into the. Well, when you mount these things on the burner, they tend to be close to the burner, so they take all the heat, and heat is what kills electronics. On the replacement unit, which is the C7061, the electronics are taken out of the purple Peeper itself and are moved to the blue box, which is typically in a control panel somewhere, which is in an environment which is at a much lower temperature than it is 2 feet off the burner. So typically the electronics last forever when they're in the blue box, as opposed to decaying and degrading when they're in the right next to the UV tube in the purple box. But here's the big price issue. Down here, the legacy unit, by the time you put it all together, it's a $3,900 purchase. And if you replace it with a C7061 and you have to put the card and the controller for it, you're down to about a $2,000 cost. That's better performance at about half the cost. This is something everybody should be aware of, because there's no reason to pay twice for the same performance that you're getting where the electronics get burned up over time because they're close to the burner. If you want to, you can rebuild these purple Peepers. Honeywell sells kits that are the coil and shutter mechanisms or the replacement UV tubes. It's the kind of thing you want to take it out of service, put it on the workbench, disassemble it, put it back together. It's typically best done there. You don't want to have a guy standing up on a scaffold to do it. But the parts are available. You can see their part number and pricing there. And we sell kits all the time to people that do this, and it can really renew a unit. The next topic that we wanted to cover is how you can reduce downtime when a flame safety actually trips out. The biggest thing in doing this is diagnostics, because when you get a trip on a unit, the question is, where do I go to fix this? I mean, rather than just starting the start button and hoping that it'll restart, what's the real problem so that we can fix the problem, so that we can get rid of this situation, particularly of nuisance trips. To get diagnostics, there's a series of things that are out there for you. The biggest one is keyboard displays. You've got an expanded annunciator. There's actually a standalone test unit to test the primary control itself. We'd like people to recognize that there is an end-of-service life on these things. They don't last forever, even though they tend to function for a very long period of time. And in some cases, there's an alternative technology that you can upgrade to that can actually reduce your downtime because inherently it has less problem with it. On the keyboard displays, they're the little box up here that plugs into the 7800 blue box control. The annunciator's got a whole bunch of LEDs on it that show you what's happening. And Modbus is used by a lot of people that have multi-burner systems because it gives them diagnostic information rapidly in a central point so that they can analyze it before they send a technician out to try and troubleshoot what the fault is. The keyboard displays are optional on all these Honeywell controls. When you buy the basic unit, it comes with just a blank cover on it. The keyboard display, you pull the cover off, plug the keyboard display in so that you get the blind one plus the optional display. You get full diagnostics. There's a key here many people aren't aware of. All the diagnostic information is actually in the standard unit. The keyboard display is just a means of looking at it. So if you've got units out there that are blind right now, and you take a keyboard display, you pop the blind cover off, you put the keyboard display on there, it's like a moving service tool. You can pop it on an existing unit and see exactly the same information that you would see if you'd had a display on there from day one. So the optional display module is as much a service tool as it is something that you can leave clipped in and on there at all the time. When you actually push the buttons on it to look at the diagnostic information in there, you get the last 6 lockouts. By nature, it gives you the lockout in terms of the first out annunciation, in terms of what tripped first to force the control to go into lockdown. There's a history on there, and then it also gives you the existing state at the moment that you go into it for the various interlock terminals, the purge timing, and the relay type. The one that people use all the time is the flame signal strength, because that's something that is typically, it's like on automobiles. It usually isn't the brain that goes out. It's the sensor that feeds the brain that is the problem on the engine. Same deal with combustion controls. Probably 50% of all problems are bad connections. Probably 40% of the remaining problems are the flame sensor, particularly if it's flame rectification with flame rods. That's the core problem. This slide just shows some of the displays that are available to you, the total cycles and run hours. I mentioned before that the new units, they actually count up to a total of 1 million cycles. The older legacy ones were down at the 100,000 limit. Gives you the fault history in terms of what's actually happening there. This one shows an example where it was pilot ignition as a problem, then it finally locked out for main flame failure. These are just 6 out of probably 50 displays that are accessible on the through the push buttons on the front of it.
Quick question
the
on
expanded
those.
annunciator.
Excuse me, quick question on those. You had said
Yes.
that you can pop that unit in and out. Can you do that while it's in operation?
Sure, yes,
Okay.
without question. Yep.
And then the next question, and maybe I'm getting ahead here, are these units, can you put them on a network so you can read the information in, somewhere else?
Yeah, that's exactly, we got a slide going about 2 ahead.
Okay.
That's exactly where the Modbus information comes out of, yes.
All right.
Yep.
Oh, thank you.
The expanded annunciator is used on bigger systems where you have lots and lots of interlocks, just as one of those kinds of things that sometimes it's easier for, depending on how the plant works, for somebody responding to a trip situation to just look at the annunciator and see what the first out unit or first out device was and troubleshoot from that rather than going through the keyboard display and figuring out from that fashion. What happens with the annunciator is that the interlocks are wired directly to the annunciator, and the annunciator has a serial link to the blue box controller, and all the control is still done in the blue box, but they communicate back and forth in terms of what's happening with the interlocks coming in that are wired directly into the annunciator. The 7800 is a tester that's a standalone unit, plugs into AC power. Because there's a universal base on it, any of the 7800 blue boxes will plug into it. And then there's this little white thing up here that is a test adapter that's selected for the given model that's plugged into it. And then with all the various switches down here, you can simulate interlock conditions to test to make sure that the 7800 box is actually functional. Given the fact that these are anywhere from probably $800 to $2,000 boxes, sometimes it pays to know whether or not you actually have a functional blue box or whether you think that it's a problem or whether it can be a problem elsewhere in the system. This is the next couple slides here will cover Modbus and how it reduces time. Where we've seen people use Modbus is particularly multi-burner applications where it gives them remote access to these burners in one central place. So if they've got a trip, it tells them which burner is out, and it gives them some history on that burner, so that rather than having to send somebody out and investigate this, the technician can go out with pre-armed with some information, and in many cases pre-armed with enough information to actually fix what the problem is, rather than just going out to try and discover what the problem is. Modbus is a widely used digital communications protocol. It actually resides, as you asked before, inside this module that pops on there. The serial hardware is in here. And again, the diagnostic information is all in the blue box itself, but it's this display that pulls it out, puts it on Modbus, which can then be read out by an HMI system. We find that people typically use Wonderware, Involution, RSView, whatever it is that you've got around that is an HMI system for pulling this information and then organizing it and displaying it for people that want to take a look at it.
So I need to...
Modbus is really a diagnostic... Yes.
I'm sorry. So I need to... I can't just buy the blue box. I have to get the blue box and the little diagnostic display to connect it to Modbus, correct?
Correct, because the actual... The diagnostic information is actually in the blue box itself. The blue box is doing the controlling and the diagnostics.
But the only way to get it out...
Right. The display actually has the Modbus output on it.
Correct. There are several different versions of the display. One version is a Modbus-only module. And then there is also the unit that has the display and the Modbus on there. So if you just want Modbus out of a blue box, you can get it.
All right, thank you.
Yep. The kind of information that comes out of Modbus is literally exactly the same stuff that you see when you punch the keys on the diagnostic display. Yeah, it's flame strength signal, first enunciation, fault code numbers. And in fact, there's probably, in reality, there's probably twice the amount of information available by Modbus, because there's also things like what version the controller is that might or might not come up on the display, but it's actually available by Modbus. It isn't stuff that people typically look at. What people typically look at is the stuff that's up here, because that's what helps them in immediate troubleshooting of a fault. Now, when people, there are people out there that use PLCs as their burner management system. And I'd just like to clarify that I don't think anybody uses Modbus from a 7800 to make a shutdown operation on. If they're using, well, I guess there's two ways of using this. You can use a PLC as your burner management system, but then you probably don't have these blue boxes, these 7800s down that are showing down here, because the PLC is taking the place of those. There are other people that run PLCs for just ordinary process control, but they want to know what's happening with the burn with the 7800s. And they're the ones that take the information and they monitor with it. And just to be clear here, if you've invested in the cost of a 7800, you want to leave the burner management control to the blue box 7800, because that's what it was designed to do. And then you want the PLC to monitor that and grab the status off of it so that you can then shoot the information off to an HMI somewhere, and or take other control steps based upon whether or not you've got burner operation or not. But you really want to leave the burner control in the blue box, because that's what they do really well. The problem of putting burner management into a PLC is that generally you have to lock that PLC down so that it can't be changed because of the inherent liability of doing burner management control on a PLC. It then becomes a safety PLC as opposed to a generic purpose PLC. Was that clear?
Yes.
Good. Go on.
Thank you.
Yep. Just to cover operational lifespan, again, we go out where we see some of these safety shutoff valves that are probably 35 years old, and they're still in service, and unfortunately a lot of these people have never done a leak test on them either. And people should just be aware that all stuff that's designed has some inherent design life in it. Some of this is coming out now because of the safety instrumented systems that are being implemented. They actually have to do these analyses to find out how long a device can operate before it's considered at the end of its useful life. Well, there are several end-of-life indicators out there. One of those is when you know what the design life is on something, you can go look at the date code and a serial number and determine whether or not it's past its end of life. Sometimes there's published data that says, yeah, it's good for a certain period of time. In other cases, it's industry experience. You know, we know that we get 10 years out of this or 5 years out of that or 12 years out of something else. The other thing is if you can't buy parts for something any longer, that's probably a really good indication that it's at the end of its useful life. Maxon, who makes safety shutoff valves, actually hired Exida to make this report. And the Exida report says that these safety shutoff valves have a 10 to 15-year lifespan on them. The indicator of the end of life is a combination of what the leak test shows you and or what the serial number shows you, because the serial number can be decoded to tell you when the valve was manufactured. And the example that's up here is that 98M means that the valve was built in 1998 and it was a manual valve. And then there's other codes in there for what the other part of the serial number is. Now, these Maxon valves can be repaired. You can put a solenoid in them. You can put an actuator motor in them. However, you can't. They don't sell the valve trim parts because they can't trust people to actually put it back together and get it tight. Because when they test these valves at the factory, they test them to ANSI Class 6 levels, which is quite a tight valve. And their experience will tell them that when you sell people a repair kit in the field, you can't really rely upon them to put it all together and have it actually be tight enough to do what the valve is designed to do in service, which is to be a safety shut-off valve and cut off all your fuel. The Exceeder report that they issued is up there on their website, and I think the next page actually shows you down here in the red rectangle that based on general field failure data, a useful life period of approximately 10 to 15 years is expected for this series of electric actuated valves and actuators. So gives you some idea of what you can expect out of those safety shutoff valves that you got on your gas trains out there. Honeywell can tell you for their UV units that they have an 8-year lifespan or a 40,000 hour ability to look at continuous luminosity. And the 8 years, interestingly enough, is 8 years of luminosity or 8 years of shelf life. The tube in a UV sensor actually degrades over time. And what that means is somebody that's bought a spare and put it on the shelf for 3 years really only has about a 5-year lifespan left on the unit when they actually put it in the service, because sitting there on the shelf, it lost whatever that was, approximately 30% of its lifespan just sitting on the shelf. By the way, you got to be. People have told me you got to be real suspect of commercial rebuilds on UV tubes, because we've had people come back to us and say, "Well, we tried one and it only lasted 3 months, so we're coming back to get the genuine OEM parts and rebuild our own rather than buying a rebuild unit." On these purple Peepers UV tubes, if you got a box on the shelf, the date code is directly underneath the little barcode up there. It might or might not be on a unit in the field because it's an adhesive tag that's on the side of the purple Peeper that actually mounts up against the burner. You'd almost have to look at it with a mirror because this threaded port up here is actually where the sight tube screws into. So you can imagine when this mounted sight tube is going into the burner sight port. And that tag has the same date code on it as the box tag does, but whether or not the tag's still there after an installation period is probably iffy. On the smaller mini Peepers, the boxes for stock products actually have the same date code on them, but the adhesive tag on the mini Peepers is a much bigger tag, wraps 2/3 of the way around. And most of the ones that we've seen installed still have that on there. The adhesive is really good. It tends to stay on there over a period of time. So the way to decode that is that the first 2 digits are the year, the next 2 digits are the week. So this 1025 would decode to 2010, 25th week. On the 7800 controls, they have a 10-year expected lifespan of 100,000 cycles. You got to pull the unit out. What we're looking at here is the wire terminals that when you look at the bottom of the unit and you flip it over, that's the tag on the bottom, and underneath the barcode at the bottom, there's a date code on there, and it decodes the same way, 1998 for the 98 at the bottom down there underneath the barcode. The third way we wanted to talk about saving money was actually looking at air-fuel or fuel-air ratio control. The way most boilers are done is that they got a jack shaft on them, and the jack shaft is a mechanical linkage between the combustion air and the fuel. Some of the more sophisticated ones have what the technicians call an Indian head ratio cam on there, which will adjust the combustion air to the fuel demand valve by characterizing the combustion air response to the fuel air demand position that it's at any given point. The problem with these is that you can easily get any ratio at any point along the curve to be off by 2 or 3%. You got mechanical slop in there, and in reality, when these things are commissioned and or tuned, because of the time it takes to do 8 or 12 stops along the curve, a lot of technicians will only do 2 or 3. They'll do the bottom point, the top point, the midpoint, and skip everything in between so that you're left at whatever they were at the last point, which might be 3% or it might be 5% off. It's hard to tell if they don't even test it. Honeywell came out with a product called ControLinks that does fuel-air ratio that eliminates the jack shaft and uses what they call parallel positioning. This amounts to putting an electric actuator on the fuel control valve and a separate actuator on the combustion air. And by characterizing these 2 control actuators and the and hence the control valve response, you get a much higher turn down ratio, which enables you to run much longer at low fire. And it also, and this becomes particularly evident because in many cases boilers are oversized to start with, and they want to run at the lower, if they're modulating boilers, they want to run at the lower range anyhow, and it gives you much better control at this lower range because you have much better fuel-air ratio control at that range rather than just the Indian head control or the mechanical linkage control. We've seen people actually increase their efficiencies from approximately 80% up to 84% for a 3% improvement continuously on these devices, which is the payoff that gives you the justification to actually go ahead with a project like this. Here's a typical diagram where it puts in. It still uses the demand controller on here. It can be retrofit onto devices that have flue gas recirculation, as they show up here. And there's an optional display panel for operators to actually look at the sequencing and the operation of it there, but that's optional. It doesn't have to be there. You can run it through the blind box if necessary. Typical paybacks on ControLinks are 6 months or less. It can be retrofit on boilers anywhere from 75 horsepower to 600 horsepower, and they've gone up to 1,500 horsepower. There are some limitations on here. We want to look at applications. We've got to make sure that these actuators can actually drive, or that they have the torque necessary to drive the control valves. We can test them with a torque wrench if necessary. We have one company that actually replaced an air damper with a newer version in order to put the system on, and they found it cost effective to do so. I think they had an 8-month payback instead of a 6-month payback because of that, but it was well within their justification to do that. Typically when we do this, we partner with a service company to do that because it's the kind of thing that it really needs a boiler service company to go in and set it up and make sure that it's tuned properly at the end in order to get the full benefits of the system. Honeywell has a second system called Delphi, which is ControLinks on steroids. And this actually, across the board, they can give you the 3% fuel-air ratio savings that Delphi can, but you can get even bigger savings because they go to a variable speed drive on the combustion air, and here you can get really big electrical savings because by the time you're talking 50 horsepower blower motors, by running these at a variable speed instead of full out, the electrical cost savings can be significant. They can also do oxygen trim depending upon whether or not it's warranted, and that can sometimes give you 1 to 2% savings in addition to the fuel-air ratio or the electrical savings on the combustion air.
Could I ask a question on the VFDs with the Honeywell product? Who do they partner with as far as the VFD goes?
The Honeywell division that sells these private labels a VFD, so they call it a Honeywell. I don't know what the name is off the top of my head. I can find out if it's important to you.
Just curious. Is it with ABB? Is it an ABB VFD?
It is not an ABB. No.
Oh.
No.
Okay.
It's somebody else's unit out there.
Okay. All right. Thanks.
Now, the big distinction, again, between the smaller system, the ControLinks, and Delphi is that Delphi also uses much higher torque actuators, which allows it to go onto systems that just require higher torque to drive valves. Maxon also offers a fuel-air control system, but this is up at the level where they're actually doing fuel and air metering systems by putting mass flow meters in the fuel and in the combustion air lines to get true trim across the entire firing rate range. And obviously this is a more costly system, but it probably gives better payback because now you're trimming out probably to the first decimal point of airflow and fuel flow as opposed to the assumed points that you're getting out of the other systems. The last one I wanted to cover on this was valve proving that goes along with the leak down tests. The conventional way for decades of installing the gas trains is to use what they call double block and bleed. And we see that in the graphic right here where the gas comes in on the left-hand side. There's the first blocking valve, and there's a second blocking valve, and between them they put a vent valve on there. And the vent valve is in there in case the first blocking valve leaks, that the gas will be vented out through a roof port, and there's a picture down here or a photograph of a vent coming out of a flat roof, which is typically what they look like. And the problem with this is that that vent valve can either stick open or leak. Well, if it sticks open, you're not going to have any, when you go to call for heat, if the vent valve sticks open, you're just going to blow your gas out the vent valve, and you won't have enough pressure to actually operate the burner. So that's a quick situation to find and rectify. The bigger problem is if this vent valve leaks, who's going to know it? Because the vent's up on the roof. You can't smell leak gas up there. I mean, it's usually in such small quantities, but the problem is it can leak for hour after hour after hour after hour. When you think the valve is shut and you're paying for gas, it's actually blowing up on the roof vent up there. And people can say, well, you know, how big a problem is this really? How common is it? Well, Honeywell actually audited a major manufacturer that had 70 burner trains on it, and 70 out of the 70 burner trains had solenoid valves that leaked. So they were, it was 7 out of 70 that leaked. And so the meter just keeps going round and round on these 70 burner trains, and they're pumping gas out the roof vent up there. And if you look at, particularly if you're considering new installations, you ought to be aware of the fact that if you're getting a system that has block and bleed with the vent on it, here are the costs that you incur. You got 30 feet of vent pipe, which is a ballpark $3,000 installation. The codes define the size of the pipe that has to go up there, and you got to figure that you also have a roof penetration. It's a potential leak. You got to add to the cost of the vent pipe a $200 solenoid, and then you have both of these potential failures. Either the solenoid coil can fail in the wrong position, or you can get the valve to leak. So there's an initial cost to it. And you can avoid that by going to something called valve proving. In valve proving, you don't have a vent valve. Instead, you have a pressure switch located between the blocking valves. And this pressure switch is activated by a 7800 blue box controller that sequences these blocking valves through a sequence to test to see whether or not there's bleed down between the valves during this initial fire-up procedure. I say initial because I think I got another diagram here. There are actually 4 approved test methods for this. One is where before you call for heat and during the purge, you can check for valve proving. You can do it after, both before or after. There's a combination of these things. People will pick one that applies best to the manner in which they operate. Some people want to come in and fire up the burner and have it on there immediately. Other people say, look, I got a 45-minute purge. It doesn't matter whether I add a 90-second valve proving sequence to that because my purge time is so long. But people can make those kind of decisions when they decide to go to this. And the idea being that when you go to valve proving, you eliminate the potential for this leak. It becomes incorporated into the system so that you're proving every time you fire up that you've got no leak in the safety shutoff valves, which actually is a big deal because it sort of goes along with this fact that people have ignored the requirement for actually looking at and leak testing these safety shutoff valves to make sure they're actually doing what they should do. Now, if you consider this, you should be aware that there are some code requirements in going to that, and those code requirements are that the safety shutoff valves have to open within a certain period of time in order for valve proving to be valid. And your safety shutoff valves would have to be evaluated to make sure that they actually do that. I know that Honeywell has some much slower valves out there that would not qualify for valve proving if you wanted to consider going to that. In converting to that, it requires a $130 gas switch, and it requires a control that's capable of that. Only the enhanced 7800 controls are capable of valve proving. The old legacy core controls do not. It also mentions on here some of the other requirements that if you were interested in that, we could go through them with you. I want to run over real quick here Maxon safety shutoff valves. I have to believe if you've got burner trains in your plant there that you have some Maxons in there because they've been the standard for safety shutoff valves for decades. Again, they test their valves at the factory to the Class 6 ANSI shutoff requirements. probably the people in the field that I've talked to actually degrade, and they say we'll accept 5 in the field just for ordinary wear and tear. They do have replaceable switches on there, and again, they got about a 10 to 15-year lifespan for life expectancy. Maxon is also known for their burners. They've got the Kinemax, which goes up to about 8 million BTU with a huge turn down. We find a lot of kinetizers out there up to 75 million BTU with about half the turn down of the Kinemax. And then the Unirad are radiant tube burners. On the Unirads that are for these radiant tube burners, there's a lot of competitive units called Eclipse SCRs out there. And the Eclipse SCR has a commonly known problem to it in that the burner goes in there, and these burners are designed for continuous ignition, and the igniters fail to ignite on these things. And the reason is that the metal gets eaten away, and the spark gap becomes too big, and the igniter can't fire across too big a spark gap. And on the center graphic right here, I'm going to show you how the Maxon unit fires all around a 360-degree area right here, and you can actually see the sparks firing here. You'll notice that the sparks go all the way around 360 degrees on a continuous basis. And what happens is every time the spark fires, it's going to eat a little tiny bit of metal away, but since this model fires all around 360 degrees instead of at a fixed spot, the erosion is constant around a 360-degree circle, and therefore the burners tend to last forever because you're picking off a little bit of metal here, a little bit of metal there, as opposed to just one point. If you go to swap these out for Eclipses, there are certain things you got to know, like the surface area and the setback distance and the mounting wall thickness and that kind of thing, but we'd go through that with you. Maxon is really known for low NOx. If you've got a mandate out there to produce less NOx from your burners, Maxon has a whole series of burners that can do that for you. Some companies have a big green push and other people don't. It really depends upon sort of a corporate edict. Maxon is a supplier of a lot of these mechanical ratio devices out there. They got the micro ratio and the synchro A, and there are various ways of doing this mechanical type of air ratio flow control that uses these screw adjustments over 12 points along the curve in order to ratio the combustion air to the fuel. Iris is a company that Honeywell purchased recently that excels at multi-fuel flame detection. This is really big where people do a blending of their fuel gases. A lot of times we hear problems that sound like, well, we have gas, but at some point or another our process produces hydrogen, and we burn it off here in order to create the heat for our boiler, but whenever we add hydrogen, we have a problem maintaining our flame detection. And this is what Iris does. When you got multi-fuels, they have the scanners that mix IR and UV detection so that you continuously get flame detection depending upon the blend of gases that you're feeding your burners. Their electronic boxes are either full-blown flame safeguard controls, or they can be just a flame detection unit that gives you a 4 to 20 signal out that's flame strength. Because a lot of people that do this kind of thing also do multi-burner, and they get into the field where they're actually using PLCs as a burner management system. And they'll use Iris as the flame detection for the burner management system. These are the kind of applications that Iris gets involved in. Big kills, hydrogen burners, black liquor recovery. I don't think they use that down there in the steel mill, but you can read them for yourself. ASCO has had for years combustion valves all the way from 3/4 inch up to 3 inch. They've had the standard visual indicators on the top for proof of closure. They have the actuators that are the solenoid style, the little green solenoids up here, or the hydro motors for the higher torque, bigger valves. They've always had the ULFM and CSA approvals. They've come out with a new design here, and the new design has the inherent flange on here because there's a lot of people that want to reduce the size of the valve train, and conventionally they've put unions or nipples between their dual block valves like this. The new style can just mate up to each other, or you can put a pressure switch in here to give you valve proving. But you can do this all with flanges to make a much shorter valve train than the old style of having to plumb it together with unions and nipples. So in the new style, they come inherently as flanges, and then if you put the adapter kit on there, then you get the MPT on the adapter. The other thing they've done is they've extended the temperature range so they all go all the way down to -40 now for the people that need really cold outdoor service valves. The new design also has a higher flow rate on it. Typically, what used to be the 2-inch valve, they now have a CV that's down in the 1.5-inch range. The mounting orientation can go roughly 270 degrees, where you can put the actuator straight up to the right or to the left. They still don't work inverted all the way at the bottom. And you also have a general purpose or NEMA 4 selection when you go for it, depending on where the valve's going to be installed for an environment. So that sort of concludes our webinar here. Do you have any questions?
Just one, but first of all, thank you very much. It was very informative. Is it possible to get the copy of this?
Yeah, you'll get an email that has it posted to the web.
Okay, good,
So,
because I'd like
you'll be able to,
I'd like to pass it on to some other people.
absolutely. If you have any questions as you dwell on it, if you want to give us a call, you can reach us at 800-9-LESMAN. You can ask for me, Mike DeLacluyse, or Dan Wisey if you're not sure who your account sales rep is.
Okay.
We will be holding more of these sort of webinars. The next one is going to be on the latest in humidity technologies, be presented by Rotronics, and it's going to be November 11th.
You'll put out an email on that?
Yeah, we'll send out an email on it, exactly.
Great.
All right.
Okay. Thank you very much.
Thank you very much for attending.
Bye.
All right. Bye-bye.